Hi everyone, welcome back to our channel. I hope you and your family members are good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic and following the very first pattern, which is monotonic stack. Today we will do the next question, which is asteroid collision. So let's read the problem statement. It says we are given an array of asteroids of integers representing asteroids. Indices of asteroid in an array represent their relative position in the space. Okay, so it denotes the relative position, and for each asteroid the absolute value represents its size. Okay, so like you can see in the asteroid array, it's 5, 10 and -5. So -5 represents the direction. Okay, it's in negative direction, like going towards left, and +10, it's 10 means positive, right? So it is higher in mass compared to -5, and it is going towards a positive direction. Okay, we have to find out the state of asteroids after all collisions. Okay, if two asteroids meet, the smaller one will always explode, and if both are of same size, both will explode. Okay, so this is a very important point ki collision, when collision will happen. But let's see the constraint here. Constraint says asteroid length will be minimum 2 and it can go till 10 power 4, and the asteroid value can go from -1000 to +1000. If you don't know, like in integer, till 10 power 9 is the safe value. Apart, like if the value goes beyond it, then we store it in double instead of integer. But as you can see, the numbers are in like till 10 power 3, so it's safe. So we don't have to worry about the integral value. Now the thing is, asteroid length, which is array length, which is n, so this will help us to identify ki whether our code will give us TLE or it will be slow. Okay, so that we will discuss later, but let's jump on to the screen. So what actually problem wants is, see, this is 5, right? So we can say keep 5 plus 5 means it's going towards the right direction. Similarly, the 10, which is going towards the right direction, and this 5 and 10, the numerical value represents the size of the asteroid. Okay, now if you talk about -5, like till here 5 and 10, so there will be no collision because both are going towards what? Right direction. Okay, yes, and with the same speed. 5 is the mass. Okay, mass means you can say the size of the asteroid, it's not the speed. Okay, so don't get confused if you read the problem. They are moving with the same speed. Okay, so it's on, like, you know, having 5 size and having 10 size, so they will never collide. Now the thing is, when -5 comes, it's moving in negative direction, so for sure this -5 will collide with this 10. Yes. Okay, another thing is in this case, if the mass or the capacity, if both 5 and -5 will be there, definitely both will collide and get vanished as per the problem statement I'm saying. Okay, so when this 10 and -5 will collide, the larger will stay and the smaller will get vanished. So as you see here, the -5 is in smaller size, so definitely -5 will get vanished, and at the end 5 and 10 will remain same, and this is the answer we have to return. Okay, so let's first find the all possible, you know, way to collide. Okay, so can I say 5 and 10, which is both positive, can they ever collide? Because they both are moving in you know, right direction. Yes. Now -5 and -6 both are moving in negative direction. Can they ever collide? No. Now -5 and +5. -5 is going in negative direction, +5 is going in positive direction. Can they ever collide? No. Okay, so what can collide? First positive and then negative, can I say? Okay, so for collision, the only special case is this positive first and then negative later. Okay, but only simple, like, you know, one case is not enough. First, so we want positive number, like A and B is there, suppose. So A is the first number, so A should be positive and B should be negative. Okay, now in this also 3 case stays. How? Suppose A is positive but 5 and B is negative but -10. Okay, so definitely they will collide, but as the question says ki shorter, like smaller will get vanished, so 5 will get vanished and 10 will, like -10 only will stay. Now second case is 5 and -2. As you can see, 5 is larger in size and -2 is smaller, so definitely -2 will get vanished, and at the end 5 will stay. Can I say this? Now as 5 and minus 5. The question says ki when the equal value or same value collide with each other, they both will get vanished, correct? So in this case, both will collide, and in our answer we have to return nothing, saying all vanished when they collide. Okay, so the very first case is A should be positive, B should be negative, and if so, then here also we have 3 different cases that we have to cover. Now, how can we do this in brute force way? Then we will see the optimized way as well. Suppose I am only I am present at 5. Okay, suppose I only have encountered 5. Okay, so with 5 I cannot decide. I need 2 elements at least to decide, right? So let's say 10 also there in the array. So if I am present at I, like here I is equal to 0. So I am having 5 and I plus 1th value I'll check. This is 10. So what was the condition? Condition was key if asteroid, let's say ARR, array of I is positive and array of I plus 1 is negative, can I say then only it can collide? Can I say this? Yes, correct. But in this case it is positive, it is also positive, means no condition of collision. Okay, now what I'll do next time, let's move our I to next, means 10. So definitely I plus 1 will become what? Minus 5. Okay, now again in the condition, is this array of I is positive? Yes it is. Is this array of I plus 1 is negative? Yes it is. So can I say collision will happen here? But who will stay? Again we have to check with 3 conditions, and those 3 conditions we'll write here. What is the three condition? Ki if array of I, correct, okay, array of I is greater than minus of array of I plus 1. Okay, why I did this? Because I know this is negative number, means minus 5. So minus 5 will become positive. So now I can compare ki if 10 is greater than 5, so definitely the positive here is in larger value. So this will stay and this will get vanish, correct? So means from our here asteroid, I have to remove this. Can I say this? Yes. But as the asteroid it has been given, it will be an integer array. So we what we'll do is we will convert this into a list, correct? And now we can write list dot remove, and from list we will remove what? Array of I plus 1. Why I plus 1? Because it is negative and it is in smaller value. So this will get vanished when collision happen. Okay, this is the very first case. Now second case, else if. Now think when both are of same value. Okay, so in that case array of I, or first check, let's negative is in larger value. Okay, so array of I plus 1. Okay, if this happens, so can I say it's you can say suppose minus 15. Okay, minus 15 and this 10. So definitely when they will collide, 10 will get vanish, correct? Minus 15 is here. But do you think when we will remove this, don't you think the size of will become like this, correct? Yes. So don't you think this 15 also needs to be compared with this 5, because when 15 will collide with 10 and 10 will get vanish, then 15 will collide with 5 also, and 5 should also get vanished, and at the end minus 15 should stay in our answer, correct? So hence what to do with for that condition? I plus 1 will be here only, correct? But as we remove this minus 10, so we should move back. Can I say this? Because we have to finish everything in that line, correct? So first we will remove list dot remove what? Array of I, because array of I is smaller, and also we will do I minus equal to 1. But when can I do this? When my I is at first index, definitely I can move back. But suppose this is the same size, array size, minus 15 and 10, definitely 10 got vanished. Do you think we should do I minus equal to 1? Because in that case I is already at 0. When you will do minus equal to 1, so it will be negative. That is not a valid index, correct? So basically what I am saying, ki before doing I minus 1, you have to check if I is greater than 0, then only do I minus equal to 1. Otherwise stop there. Okay, done. Now the very third condition is else case you will mention. So definitely it shows ki array of I and array of I plus 1 are in opposite sign but having same value, so both will get vanish. So in this case what we'll do, in this case from our list we have to remove both elements. What? Array of I also, yes, and dot remove array of I plus 1 also, yes, and now this is 10, this is minus 10, then only it will remove, right? Both are same, so we will remove this, we will remove this, done. Okay, but suppose here is minus 10 also, so this minus 10 will remove this 5, but we are only considering I and I plus 1. So if we lose our I and I plus 1, so don't you think the next element, like after removal, definitely the array will become 5 and minus 10, correct? So I should represent this 5 na, yes or no? Then only you can compare with I plus 1. I hope this is clear till now. Okay, so as I removed I and I plus 1, so basically again I will check ki can I do I minus 1 if that I is valid. Okay, so after removal also again I will check ki if my I is positive, then I would like to do minus equal to 1, because after removal of 10 and minus 10, suppose minus 10 is also here, so now after removal the array will become 5 and minus 10, and now I want this to compare, and this 5 and 10 I will only be able to compare when my I will point to 5 and I plus 1 will point to minus 10. So hence as our I was here, so I want this to go for I minus 1 only when my I is greater than 0. Okay, so this is the brute force code, but if you see here again this array, like this I value you have to run in a for loop or a while loop. Okay, not for loop, basically while loop. So you will write while what I is less than what, asteroid length, yes, dot length minus 1. Minus 1, why? Because we are actually considering I and I plus 1, so we cannot run till last index. Okay, so our I needs to stop at second last index. Okay, so if you see the time complexity is only O of n, because we are running only one while loop. No, it's not, because obviously this one while loop you are running inside, but don't you think you are running in a while loop? Why I said not for loop? You are running in a while loop because for loop means as you can see we are removing the element from the list. So can I say instead of asteroid now the list you made, right? So I want to run till list dot length. Okay, so as we are removing elements from the list, correct, so list size is variable, and also we are doing this, if you read this line I minus equal to 1. So this is only possible with while loop, because while does not care ki suppose a size is 10. So while loop does not care ki you are running only for 10 or you are running for 100 size, n square or n cube, correct? But for loop do care. So as we are moving this, suppose I is at third index, okay, or second index, again you did I minus 1, again I came here, again it is running, again you did I minus 1, again it came here, again it's running, correct? So that we want in this, so hence we closed in while instead of for loop. Now the thing is, obviously if one while loop everyone can think of O of n, but inside this again we are doing this I minus 1, correct? Yes. So we are removing, like you are moving our pointer back and again starting, correct? So hence this is nested, correct? So it's not like I is only pointing to one index at a time and it is not coming back again. Here it's coming back again to remove all such elements. Can I say this? So hence the time complexity will be O of n square. But as you saw ki n was 10 power 4, so n square code can go till 10 power 8, correct? And it will be slower. It might give you TLE in different languages, but it will be very slow if it gets submitted, and hence you need to optimize this. So here is the code what we discussed, and if you didn't get it ki how can we do, then here is the exact code. Okay, we converted the asteroid into a list because we want to remove we want to remove the elements from the list, and with array integer array it's not possible, so hence we converted this into list. Run the while loop till I hit the second last index and read A and B value with the help of I and I plus 1th index. Now they can only collide when A is positive and B is negative, and the three different conditions here, and if not then we'll keep on moving our I plus plus ahead. Okay, and at the end, as we have saved in a list and the return type is integer, So hence we need to store this in integer array back, and that we can return. So now we can run this code, and let's see, it passed. So now let's try to submit this code, and you can see it's very slow because the time complexity is O of n square, means 10 power 8, correct? So now we have to optimize this. Yes, but as we have already discussed, whenever we move ahead and again we came back to check something like, you know, greater value, smaller value, that's what we are doing here, right? So instead of finding like in next greater element or next smaller element, if you are following our playlist, we already solved these questions. I'll add the link somewhere here, you can check it out. So whenever we do this here, obviously we are going back to pop, correct, to find that conditional value with what it can collide, right? So here also we are going back. Once we travel ahead, then again coming back to find greater or smaller. So whenever this condition happens, we always prefer stack data structure there, correct? So here also the optimized solution will be stack data structure. Yes, but how can we do with stack? Okay, so remember, we can do in both the directions, from left to right also, or from right to left also. In this code I'll show you from left to right, and you can try on your own if you understood this from right to left direction. Okay, so first I encountered this 5, okay, and we have nothing to compare, so we can simply put in stack 5. Done. Now we'll move to 10, correct? So what do you think? Stack value is storing the previous values, correct? And for collision, what was the condition? Key previous value needs to be positive, then it will move towards right direction, and the current value needs to be negative, then it will move towards left direction, and then the collision can happen, correct? So this I can write ki for int I is equal to 0 to I less than asteroid length, correct? Yes, and I plus plus. Now what I have to do? I have to check ki while my stack is not empty, okay, why only while loop, I'll show you. While stack is not empty, correct, and what? And stack dot peak, which is top element, is positive, correct? And the current element, let's say A, we are representing asteroid of I, like this, A is equal to asteroid of I, okay, and A is negative, correct? Okay, again in this case, so it's not going to happen, correct? So let's add the 10 also here. Okay, now our A is pointing to -5. Now we can say ki yes, the topmost element is positive and the current value is negative. So now the collision can happen. But if you remember, when can we pop this? Like there were 3 conditions, remember? When like if positive number is smaller in value, then we will pop this. If negative number is in smaller in value, which we are holding by A, then we will not push in the stack itself. Means basically we collided this, okay, means we vanished this. Now if both are of same value, suppose +5 and -5, then we will pop this so that it will get removed from stack and will not push this in stack. Why we are doing? Because at the end whatever will be present in our stack, that will be our final answer, correct? So when we don't want, which we already there in the stack, that we want to pop it, and when we don't want that element which we are holding it in a variable A, that we will not push in the stack. Okay, so currently as we are looking for the stack, so we have to check that condition where we can pop from the stack. So when we can pop, can I say when the integral value is lesser than the negative one, correct? Yes. So what I'll do with this AND condition, key AND stack dot peak is what? Smaller than minus of A. Can I say this? Can I say this? Yes. So what will happen? Suppose this is 15. So minus 15 means it will be plus 15. So 10 is less than minus 15. This is what it means. So hence we will pop this, means stack dot pop, and anyhow this should remain this in the stack, correct? And why we added this while loop? Because minus 15 will vanish this 10, yes, but minus 15 will vanish this 5 also, na? So hence we'll go in the stack to check the next one, 5, and hence again if it is smaller, which is, I will pop it. So at the end our 15, which is minus 15, will stay, correct? So hence we added this while loop instead of a single if condition. Okay, so if the condition passed, we will do stack dot pop. Done. Now in this case, if you see, this is minus 5 and this is plus 10. They are opposite in sign, but plus 10 will not vanish. So hence will not pop from stack. but we will not add this because this needs to be vanished, so we will not add this. So for this we have to write another condition. Okay, so for that what we have to write, ki if again stack is not empty. But before that, let's see another popping condition. When I want to pop when this is 5, this is 5, so definitely I want to pop this also, and I don't want to push this, correct? So the second popping condition is equal to. So what we have to check, ki if stack is not empty and what, and A is negative. Okay, if it is so, then there can two possibilities. What it can be, ki A is negative, yes, and stack is not empty. So there can be two possibilities. Those are, this can, the positive number like stack dot peak can be larger in value. Okay, so in that condition we don't want to push this, and this can be 5. So in that condition we want to pop this, but we don't want to push this, correct? So in both the conditions we don't want to push this. So hence if this condition run, then we write in else condition to push in stack what, A. Okay, correct, done. Now again what I said, in if the stack is not empty and my A is negative, so stack is not empty, yes, and A is negative, yes. So there can be two possibilities. Very first is ki in our stack the positive number is larger in value. If it is so, then we don't want to push this. Done. Now second, it can be of same value, because if it is smaller in value, suppose 4, that we already considered in this while loop, na. Okay, so only two possibilities. First, if it is greater, and second, if it is of same value. So if it is of same value, definitely we don't want, like we want to pop this and we don't want to push this. So in both the conditions we don't want to push this. So if this condition runs, I will not push. So hence I added this in else condition. Done. Now inside this we have to check if our stack, like popping condition should be only possible when a stack dot peak value and the negative value holds the same numerical value. So stack dot peak is equal to minus A. Then I can say I don't want to push. Obviously it will not be, because this if case run, so it will not be pushed. Minus 5 will not be pushed. But if it is of same value, means minus 5, and in stack we have 5, so that 5 we want to pop from our stack. So hence that will do stack dot pop, and that's it. At the end what will be here, so as you can see minus 5, this is larger in value, so we will not pop from stack, but we will not push this minus 5. So at the end we will have this 5, 10 and 5, but we cannot return our stack because the expected is integer array. So if we will, like how can we take the elements from stack and push it back? So if we will push like in answer array, okay, like if we'll pop from 10 and we'll push here, then we'll pop 5 and then we'll push here, it will become reverse, correct? So what we'll do, we already know the size of stack, so we will make the answer integer array of answer new int of size what, stack dot size. Okay, stack dot size will make the array. Now we'll run the for loop for int I is equal to length. Okay, we don't want to pop this from the end and push in the starting, otherwise it will become reverse, correct? So what I'll do, I'll read the index from stack dot size minus 1, means from end I greater than equal to 0 and I minus minus. So first index will be what, from the last. So what we'll do, in our answer of I we will put stack dot pop. I hope you get this. So now what will happen, 10 will get popped, and in our answers at last index 10 will be appended. Now 5 will get popped, and as we move I minus minus, so now here we will put 5, and in this order we do not need to reverse the entire integer array to return our answer, correct? So in just by taking just O of n we can do this. Done. So this is our code. Now let's see the time complexity here. Definitely we are running this for O of n size, and here we are running this while loop, and you can think of nested, but it is not. Why? Because this for loop is running for O of n, but this while loop is only running to pop elements, correct? And in the worst case what you can do is, every element you will push this in the stack, and this while loop will run to pop it. So in worst condition it will pop every single element at once, means n elements by taking O of n times. Okay, It's not like for every ith element we are putting multiple elements in the stack and we are popping everything, correct? So hence it's O of n plus O of n, which is O of 2n, which is linear only, okay? And at the end plus O of n, basically you are taking to pop from the stack and to push in the integer array to return the answer. So hence it's linear solution. So as we discussed, let's jump onto the code. We will first make the stack and we will run the for loop to read every element, and in the stack we will pop only when the stack is not empty and the current element is negative and stack peak value is positive, and as well as the stack peak value is having smaller, means positive value having smaller value compared to the negative one, then we will pop. Now if stack is not empty and A is negative, correct, and stack dot peak is positive, then okay, I missed this, sorry, A was negative and stack dot peak is positive. This is very compulsory to check this, otherwise what will happen, A negative and stack dot P negative also will be considered here, okay? Now if this if condition passes, means there can be two possibilities as discussed, ki either the stack positive value can be of equal in value, means plus 5 and minus 5, or the positive can be of larger in value. So here if it is equal, then we will pop, and as we mentioned the push condition in else, so anyhow that is not going to be pushed. And even if the stack, like the positive value, is not equal, means suppose minus 5 and we have plus 6, correct? So first plus 6 and then minus 5, so obviously they will collide, but 6 will stay and minus 5 will get vanish. So hence we don't want to add that in our stack, so hence we added this in else case. Right now this is our Java code, and I hope you understood the brute force and optimized code. And if in case you guys are for Python background, here is the similar approach and more simpler code, because in Python we write very less, right? And here is your C++ code with the similar logic. If you understood, you can do on your own as well, but it's just for you to check if you have written correctly or not. And if you understood this approach, then definitely we can go in the sheet and we can mark the next question as done. And as we are following the questions pattern wise, so I hope you are getting the whole reason key, and any array or string based questions also, when to apply two pointer sliding window concepts and when to apply stack. Okay, and if you are following my playlist, then definitely you will be able to answer on your own, and if no, then what are you waiting for? Just check out my playlist, check out this sheet. If you don't have the link, I'll definitely add in the description, you can get the link from there. And if in case you have any doubt, do let me know in the comment section. And one humble request, if you really like the video and if you understood each and every concept, then please do hit the like button and subscribe the channel if not yet subscribed, and please do share this channel to your friends if you feel this channel can help you grow in learning DSA in depth and with pattern recognition. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.